Let's begin. Today's August 21st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 11, 18, 21, and 22. And the puzzle uses the green verification cards. The code above is your way to find more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and the Turing Machine will let us know whether its value is even or odd. Criteria card B will look at the 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe all 3 are 3. Criteria card C will look at our first 2 digits, triangle and square, and compare them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card D will look at our 3 digits, triangle, square, and circle, add them up, and the Turing Machine will let us know whether the total sum is an even quantity or an odd quantity. Criteria card E will look at our 3-digit solution and will let us know a little bit about its structure, so to speak. It'll let us know whether there is a pair in our solution, as in the example 131, or alternatively no pair. But there are 2 scenarios, one where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again looks at our 3-digit solution, but this time will let us know a little bit about the ordering of the digits, from triangle to square to circle. Should the numbers be in an ascending order, meaning that they're increasing, as in the example 135, or are they in a descending order or decreasing, as in the example 421, or potentially they could have no order. Let's look at the example 231. Notice that from 2 to 3 it increases, but then from 3 to 1 it decreases. So that shift from increasing to decreasing, or alternatively in a different scenario where it's decreasing then increasing, they both have that shift. And that shift is one way to describe that the 3-digit code has no order. We've also seen in other puzzles where if you have a consecutive digits, meaning that they're next to each other, and they're equal, that is also another way you can define a 3-digit code to have no order, since if they're identical, there is no change. So therefore, no order. And of course, remember that the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is a little bit about that first digit. So let's go ahead and test criteria card A. Okay, so the Turing Machine does not approve of my choice. I did choose an odd 3. Since it disapproves of that, it's basically letting me know that triangle is actually an even digit. So let's go ahead and type that up in our notes for section A. A triangle is an even digit. And because it is even, that means I can cross out all the odds for triangle. So crossing out 1, 3, and 5. So the next thing I'd like to test is criteria card D. So notice that the Turing Machine does not approve, and notice that the criteria card has us adding up the digits. So let's go ahead and add up the digits in my proposal, and that's 3 plus 1 is 4, 4 plus 4 is 8. That's an even quantity, but the Turing Machine does not approve of it. So it's letting me know that, in fact, the sum of the 3 digits should be odd. So let's go ahead and type that up in our notes for section D. and that is that triangle plus square plus circle should be an odd quantity. And since the total sum is odd, let's go revisit. We know that triangle has to be even. So if we add an even and an odd, that sum is odd. But if we want the overall sum to remain odd, we have to add an even to it. So what that's basically telling us is that among square and circle, one is even, the other is odd. So that way the overall sum is in fact odd. So we probably won't write up a note for that just yet because we don't know whether it's square or circle that are, which one's even among them. We just know that we do have that. And since we do have basically a single odd, notice criteria card B, there can only be one 3. Either there is a 3 or there isn't. So it's either there is one 3 or there are no 3s. So we could test that, but I think instead, I'm going to test criteria card E. Okay, so the Turing Machine does approve of my proposal. Notice that I do have all distinct digits. That falls under the no pairs option. Now, as I mentioned, there are two possibilities, but the fact that we have a mixture of even and odds means that it can't be a single digit repeated 3 times, right? Since that means it's either they're all even or they're all odd. But we know that our solution has a mixture. So we know that means that all digits are distinct or there are no repetitions. So let's go ahead and type that up in our notes for section E. And we'll say that the solution has, we'll just say no pairs. And in addition, because again, we do know we have 2 evens and a single odd, that means the solution is going to be a 2, a 4, and an odd. Now, I don't know the order of them, but I do know that our solution has to contain 2, 4, because they have to be distinct, non-repeating, even digits, and of course, that odd. Okay, well that does it for this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we didn't test criteria card B. That lets us know whether there is a 3 or not. We can also compare, or we didn't compare triangle and square. And remember, since they're all distinct, we know that triangle and square cannot be equal. So at least we know they can't be equal. And then, of course, there is the criteria card that lets us know a little bit about the ordering of the digits. So let's see. So I guess the big question is, perhaps, which one is odd? Is it square or circle? So let's see. What if, is there anything, so we can compare. It would be very helpful if somehow we knew square were even, so that the first 2 were evens and we'd know whether it's 2, 4 or 4, 2, and then the last one would be the odd. But I don't have any clear indication of that. How can we know for sure that the middle is even? Maybe perhaps if it was ascending, well, if it's ascending, well, yeah, maybe if it's ascending, it could be 2, 3, 4, or it could be 2, 4, 5. And the fact that there's no 3 would disqualify 2, 3, 4, and would force it to 2, 4, 5. That's a possibility. But if it's ascending, let's see, if it's ascending, then we would know for sure that triangle had to be smaller than square. And that would mean that this card is irrelevant. And I think similarly, if it's descending, we know that square should be greater than square. Or sorry, I should say triangle is greater than square. And again, that would make this card irrelevant. So I think we know that there's no order to our solution based on that sort of thinking. So we're looking at a solution that has no order. And so depending on how criteria card C plays out, we know it could be increasing and then it pivots down to decreasing, or vice versa. It could be decreasing and then it pivots to increasing. And perhaps maybe there is no 3, maybe like 4, 2, 5 or 2, 4, 1. But again, how do we know that square is even? Well, maybe the ordering will be eliminating, either a 1 or a 5, just based on the ordering. And maybe there's a 3 or not. Yeah, I don't quite see where that odd should go. How can we figure that out? Yeah, I just don't see it. So I'm going to go with the possibility that, yes, the middle digit is also even. And so I'm going to go with 2, 4. Well, I haven't really quite convinced myself. Can we somehow... Yeah, very interesting. I just don't see where that odd fits. If there are no 3s, yeah, wow. Okay, well, I gotta try something. So, again, I'm gonna go with, let's see, I don't quite remember what I said before, but let's go with 4, 2, and we'll just say 5. 4, 2, 5. And see where that takes us. Okay, so let's go ahead and test criteria card C, and let's see what we can determine about the ordering or the comparison of triangle and square. So let's test C. Okay, so it is true that triangle is greater than square. Since I have a 4 for triangle and 2 for square, 4 is greater than 2, therefore triangle is greater than square. So let's go ahead and type that up in our notes for section C. And again, that is triangle is greater than square. And we should, I believe, be able to cross out some values. So if triangle needs to be greater than square, then I think, well, triangle's already at 2. Well, let's see. I guess triangle cannot, or sorry, square cannot be a 5, because if square were 5 and triangle needs to be greater, there's nothing greater than 5. So I think it's safe to be able to cross out the 5. Now what about that 4? Can square be 4? Yeah, I think we can also cross out square as 4, because if square were 4 and triangle needs to be greater, there is no other even value that's greater than 4. So yeah, I think we can cross out the 4. Now I think at this point, yeah, I think that may be it, because there is something that's bigger than 3. That's 4. There's something greater than 2. That's 4. And there's something greater than 1. And that's 2 or 4. So I think, yeah, I think everything is okay. Okay, so we're down to 1, 2, or 3 for square. And, well, let's see, is there a 3 or not? I did not choose a 3, so let's see what we get for criteria card B. Okay, so it does not approve of the absence of 3. I don't have a 3. The Turing machine does not like that. So it's telling me, yes, there is a 3. And because we do have an odd, that means all the 1s and 5s should be canceled. Very interesting. Okay, so we'll type it up as there is a single 3-digit in the solution. And of course, as I mentioned, there should be no other odds. So that means for square, I can cross out the 1. So it still can be a 3. And for circle, I can cross out the 1 and the 5. Very interesting indeed. Okay, so let's see. After this, and we did sort of deduce, so I will type it up and say that we've deduced, or deduced that there is no order. Oops, did I type that right? There is no order. Okay, so let's take a look. So again, we do know that triangle has to be greater. So that means, actually, very interesting, triangle can't be 2, because there is nothing smaller than 2. So that forces triangle to be 4. Okay, and so I think we can say, again, based on our deduction, that there is no no order and no duplicates. I don't think it could be 4, 3, because it needs to pivot and there are no duplicates. So it can't be 4, 3, 3, and it can't be 4, 3, 4. So that means square can't be 3. Very interesting. Okay, so yeah, so somehow these combination of cards have actually informed us that the first 2 digits are even. So it's got to be 4, 2, 3. And again, you can't have a duplicate 4 because there are no duplicates. Wow, very interesting. So it looks like the solution is 4, 2, 3. Let's go ahead and type that up. I apologize, the computer seems to be lagging a bit because it's not typed up my solution just yet. There we go, 423, and it does seem, let's see, so let's kind of do a quick review. Is the first digit even? Yes. There is a single 3 in our solution, yes. The first digit is greater than the middle, yeah, 4 is greater than 2. The sum is odd, it is indeed. There are no pairs, they're all distinct, and we do have a 2, a 4, and an odd, yes. And finally, there's no order, yeah, because it goes from 4 to 2, so it decreased, but then it increased from 2 to 3. So yeah, that has no order. Okay, fantastic. Well, let's actually go verify. 423. Okay, 423. Fantastic. So yes, that was the correct solution. But let's actually see how we did against the Turing machine. So if we go back, notice that we have 6 criteria cards, but we only had to do 5 test 5 questions. We were able to deduce criteria card F as being no order. So whenever you have, or whenever you do a lesser amount of questions versus Turing versus criteria cards, that's always a great indicator of actually beating the Turing machine. So notice that we did A, D, E in the first round, and we got the first 2 wrong, and then we did B, C in the second round, and we got B incorrect. So let's type that up. So A, D, E in the first round. So A was incorrect, D was incorrect, but E was correct. And in the second round, B was incorrect, and C was correct. And of course, we deduced what F was. So how do we do? Okay, so we beat the Turing machine by 1 question. Small margin, but it's still a win. And so, yeah, I thought this was a very interesting puzzle. Like I said, I couldn't visualize whether square was even or circle was even, but it's the series of criteria cards and what the end conditions are for each, that somehow it just turned out to have square be even. I did not see that. Well, that's always an interesting puzzle to me when some interesting result pops up. I always like those. Well, I hope you did too. Please do add comments if you notice some sort of efficiency or just a thought. And of course, do give it a thumbs up if you liked it so that more people can find this channel. And of course, hit the subscribe button so that you don't miss out on the next video. Well, until next time, have a great one.